Hey guys, I've been playing with my new module here. This is a serial or USB controlled 8 relay module I got from China for about $11. And as you can see, I got it working, but it took some doing to get here. I ran into some issues that I'd like to share with you. Before we specifically talk about this module, let's discuss about what a relay is first. So what is a relay? A relay is just a magnetic switch. So imagine yourself, you have a switch. Hang on a second, I have a switch. Here's a switch that I wire up to my multimeter. So basically, if you have this connection connected, it makes a beep. And all it is I just wire it such that it goes to the switch. And the switch, as you know, has 3 leads, the middle one, and 2 end ones, and depending on whether this is going this way or the other way, either the middle or that side is connected, or the middle and this side is connected. So when it's going this way, these two are connected. The multimeter is only looking at those two. Nothing happens, but if I switch this way, then those two will get connected, and therefore you hear the annoying beep. So that's a switch, and a relay is nothing but a switch like this. So imagine you have this like this, and then you have the thing that moves back and forth. You know, it goes this way or this way. And the only thing that makes it into a relay is that they put a coil here, an electromagnetic coil. So when you activate this coil, you put power to here, it will actually pull that switch down and it will connect it to this side. And then when you don't have any power on this coil, it will spring back. There's actually a spring that springs it back to that side. Now that we talk about the individual relay, one of these guys here, let's talk about how they interface with the Arduino or the ESP or whatever controller you want to drive it with. Typically, what happens is the relay are completely separate from each other, and they basically have driving circuit like either a MOSFET or a transistor or something, because the Arduino cannot drive these directly. It takes too much current to drive that coil, to drive this coil over here. So there usually is a transistor or something. Let's see, something like this. So there's a resistor here that goes to ground, and this goes to like D0 or something from the Arduino. So the Arduino will send a signal that connects these two here, and so this goes to plus, and so now there's power here that activates it. The switch trip to this side. So that's typically what happened. And usually when you have 8 of these, you basically have 8 separate circuits exactly like that. And because of that, then it actually require 8 digital pins. So it takes a lot of pins to drive these relays. What is cool about this one is that it has this chip that instead of separately driving these, they put another chip right here that drives those 8 transistors that's also built in somewhere. And you drive this using a serial command now. So it takes basically one serial coming in. That's from the Arduino will be transmit. This will be on the RX, the receive side on this side. And then it also sends back the identification as to what it is. So this one is not really that important. Well, of course, it's important for us to be able to control these relays, but the notification is probably not that important. But notice that now, at the maximum, we only take 2 pins of the Arduino rather than 8 pins to drive all 8 relays. So I thought that was pretty cool. Okay, let's now talk about how I wired this to the Arduino Nano over here. As I mentioned before, instead of having individual pins from the Arduino controlling each individual relay, we have basically the RX and TX. Those are the pins over here. So the leftmost is the RX, the white wire, and then the second one is the TX. So this he receives from the Arduino on the white wire. He transmits to the Arduino on the blue wire, and then the other two is ground and 5 volts. And because these relays take a lot of power, I discovered that I have to power them separately from a wall wart, and the Arduino basically only supplies the RX-TX. There's no power coming from the Arduino to this board right here. So that's that. Let's talk a little bit about how I wire the relay themselves. So remember we talked about the coil. The coil is basically driven by that chip. That chip talks to the Arduino through the RxTX over here. The other side that are actually switched, that is completely isolated, that's another thing I forgot to mention. These terminals over here, and each of them has 3 pins similar to the switch we talked about before. So the switch, by default, if it is unpowered, it will connect to this side, and then when you power the relay, it will connect to that side. So the middle is basically the moving piece. When it's unpowered, it just spring loaded to this side, and then when it's powered, we pull it to that side using the electromagnet that is within the relay that is controlled by that chip that is controlled by the Arduino. So this is where I bought mine, icstation.com, but I've seen this module available from eBay, and apparently they raised the price, but don't worry, they regularly have sales. I got mine for like $11.04 shipped. So let's talk a little bit about the module itself first. I got this 8-channel model, but they also have a 4-channel model that is basically the same thing with only 4 relay, but it has the same USB and serial interface. So you derive this using just the serial port from the Arduino or a USB port from the PC. And they also have a 2-channel model, but this is the one I bought. So let's take a look at the description here. So it has a micro USB. I forgot to mention the type of USB. It's the really tiny one, the one that's on a cell phone and stuff. And it comes with a program if you really want to use it with a PC. Yeah, right here you can download the app here, and with this application you don't need an Arduino and you can control the relays using a PC. There's just buttons and stuff. It's a Windows only app, however. It uses 5 volts, so it's perfect for the Arduino. And these are the different models. So the one I got is the 8-channel model here, but they also have a 4-channel and a 2-channel, as you saw. These are current requirement, of course. With 8 relays it takes more power. And then what else is different? They're all 9600 baud, so that's how you set up your Arduino or your PC to communicate with this device. And I don't know what that is. And the model I got has this power interface, which unfortunately for me it does not seem to work very well at all. I end up not using that, and end up putting power through one of these pins here. This is the back. You can see that it has ground and 5 volts. That's what I use to power the relay. And then the TXRX is connected to the Arduino, of course. So let's look at some code. I started with the serial example. Communication serial call response. And this is all you need really to talk to the relay module, because all you need is a serial communication. So this is a pretty good example on how you would open the serial port, and then if you have a Leonardo, apparently you need these few lines here, and then to listen. So if you need to listen from the data coming from the module to the Arduino, that's a read. If you need to send something, which is what we really need to do, is to do a serial write, and you send it whatever data you want to write to the module. However, I discovered that this is really annoying, because this same serial port that is being used by the USB, if you hook up the TXRX on the Nano to the module, those two TXRX and the USB TXRX that's being used for our code here, as we upload code, is the same 2 pins. And so while you're uploading code, the relay will just go bonkers because it's getting all this gibberish. And so I end up using the software serial, another example, somewhere in here. I got a lot of modules, huh? A lot of libraries, but it's a software serial. You could find it. And with that, now all of a sudden we have 2 serial ports, which is really cool, because now we could use one of them, this one here. It's just for the debugging, so we could actually print something to our serial monitor on the Arduino side, on the PC side, I mean. And you can use this other one, the software serial. My serial is a software serial, to actually talk to the module, and those are connected to pin 10 and 11. Those are these two pins right here, 10 and 11, instead of their usual pin 0 and 1 on the Nano. So 0 and 1 is still being shared by this, and 10 and 11 is being used by this to talk to the relay module. So now they are completely independent and they don't go interrupt each other. Oh yeah, we need to talk about the actual data that we're sending back and forth. So I started, of course, with this module, with this document. Whoa, look, the price is lower. I told you, all you need to do is wait a little while and the price fluctuates. Okay, we already talked about those. This is pretty clear how to wire it up. Okay, this is where I was starting to get confused. What in the world is an upper monitor? And what are these two numbers for? By experimentation, I discovered that this is kind of like an initialized byte, and you have to send this to the module, and when you send that, the module will send back one of these three things. Mine actually sent this one, which is, I guess they just picked some numbers saying what model it is. These are probably being used by the PC program to know how to change the user interface, allow 2, 4, or 8 buttons on the PC screen. But for us, we don't care. However, you have to send this. Until you send this to the module is unresponsive. So this is kind of like, hey module, pay attention to me. And then it will tell us back which one it is, which I will ignore. And then once that happens, then you send this command, and that command will be followed by a byte, and the bits in the byte will represent these relays right here. So I think that's 0 over here. Yeah, so that's bit 0, 1, 2, 3, 4, 5, 6, 7. So it's bit 0 through 7. And the bit pattern that you send after the 51 determine which one of these relays will turn on. And in theory, you should be able to just set the bit pattern and then send them all using a 51. Let's say you want these two, so that's a value of 1, 2, 4, and etc. So let's say you want these two, you should be able to send a 51 and a 3. 1 plus 2 is 3, and then it will turn on both of those, and that works. However, when I try to turn on many more, there's some threshold in which things becomes unreliable. And my theory is that basically the relays, when you first turn it on, it takes a lot of current, takes a lot of power, and maybe even create a power surge on my adapter here, and there's just not enough. And so what I end up doing is, no matter how many I need to turn on, I turn it on and off one at a time. But you could do that so quickly that, as you saw in the blink example, they are practically simultaneous. So I think that's about it that I want to share here. Yeah, these are the bits that I just now mentioned, and the relay I think they're numbered on the silk screen here. So let's go back to code. So I noticed while I was explaining earlier that this is still called my serial from the example. I think it's not very descriptive, so let's rename it. Maybe relay is a lot more descriptive than my serial. So let's make sure it's still compiled. Good. So a couple variables. Bit pattern is the pattern that is represent the relays. Remember, we talk about those bits that is in the relay, and then when we're sending pattern, we'll send these patterns. And I put in a variable so that way, as we change the bits to turn things off and on, we will always maintain all 8 bits, so we won't mess up what was there before. So that's what this is for. And pref index is just an index that is used by some of the example routines here. So we talked about that already. Okay, here's the init module. Init module is just this one line basically here, and this is the 50 we talked about that we got from the documentation online. So when unless we send this 50 at the beginning of the startup of the Arduino, the relay will not listen to us. So it is very important that we send this 50. And once we send that 50, it sends back the actual model number, remember that? And in this case, we ignore it. I also have another one here that I comment out that basically will wait as long as there is nothing coming back from the module, from the relay module. I wait for 100 milliseconds, and then I print this in the debugger here. What is this called? Serial monitor, on the serial monitor right here. So it will actually display things here, and then it will actually send the same thing, this 50. And then hopefully as soon as we send that 50, it sends back the model number, and it will say, hey, that's now available, so now we can go read that character, which will be one of these 3 characters. And then we say yes, received, and then we say what it was, and then we're ready to go to our main loop, which is, actually I put a delay in here, I'm not sure why, I don't know if it's necessary. So after we get set up, then we go to the loop, and the loop, I got a couple examples here, so let's run this one. So let's upload it, and let me turn on the power to the relay on the wall wart here. Oh, that's an interesting thing. I did not have this powered, and the sketch has run, and so the initialization to send the 50 already happened. And as I mentioned before, if he doesn't see that 50, he's not listening, so he's just sitting there now. But if we reset this, it's going to go run through that setup again, and there it is. So it's actually working. So remember this part here. So setup already ran, and because I upload and it ran setup, and then I turn on the power, so it actually, the relay module missed this part, and it was not listening, even though later on we run this blink, and it's just ignoring everything that the blink does. Let me turn on the power so I could talk without getting distracted, and we'll talk about this blink. So let me find that. It's very simple. All it does is turn all of them on and turn all of them off with a 1 second delay. So let's dig deeper. All on is a very simple routine that goes from 0 through 7, and passing the 0 through 7 right here, passing the second parameter as 0. The relay, for whatever reason, they choose 0 to mean turn on the relay, power the relay, and 1 to mean do not power the relay. So they're kind of backward, but I follow along, so that way I don't have to do a mental switch saying in my code it'll be this way and the module will be that way. So it's consistent. So it's always 0 means power on the relay. So we'll go dig deeper, and oops, that's not it. And there it is, switch. Switch taking 2 parameters. One of them is which relay we want to set, and the other one is what state to put that relay into. And there is a familiar 51 that we talked about earlier. So we send a 51 saying, I'm about to tell you the bit pattern for the relays. And then if this state that we pass in is a 1, we're going to change the bit pattern. That's the global we talked about earlier, and the variable declaration way up above. So we say we're going to change the bit pattern such that we want to set the pattern for that particular relay. So if this is the 0th bit, we'll say the 0th bit should be turn on, meaning we're going to turn it off, because state 1 means turn off. It's really backward. So in the other way is we say if somebody says go turn this bit to 0, we're going to clear that bit. So that's it right there. Is basically we flipped the state for the proper bit on the relay. Then we do the relay write to actually send it to the relay module. So basically, if you think of these as actual bits in a byte, you could just see that, you know, whatever bit pattern you put in here is what those the relays is going to do. You know, 1 means off, 0 means on, backward. So that's that. That's a switch, and we just, by using this switch, we could do all kinds of pattern in here. And currently I only have connected it to an LED with the current limiting resistor, but there's no reason why you can't turn on and off actual mains power. Okay, back to the code. Let's go back to all on or off. All off is exactly the same, except we're setting the switch. Where'd it go? Okay, here it is. We're setting this the state to 1, meaning off. I know it's backward. And then let's see, is there anything else interesting? I think you guys could probably just look at the actual code on your own. Leave a question on the comment if you have any questions. But let's play with some of the other examples that I got here. So that was the blank, and this was my first example actually. I'm going to upload this, and as soon as it's done, I'm going to turn on the power, and I probably will end up having to do the reset thing again. Yep. And there it is. And once the sketch is up there, we could basically power down the whole thing and power up the whole thing. It works just fine. And then I say, hey, if I could blink them one at a time, I should be able to also hook up a potentiometer and control which one to blink. And so now it depends on what the position of the potentiometer here. It moves around. That was kind of cool, but then I got curious as to how fast I could send this thing back and forth. So check this out. Normally I think I set it at like 1 second, but this is at 70 milliseconds, and it's pretty fast. But I got down to 20. Pretty crazy. Yeah, I'm sure this is not what it's meant to be, and then I think if you use mains power, you will probably decrease the life expectancy of the relay, and it's pretty annoying how noisy it is. But having fun. If you guys have any questions, leave a comment. I'll talk to you guys in the next video. Bye bye.